Hello Year 11. Today we'll be going through this part of the specification. We won't go through all of it though, just go through these parts here. So there's a few separation techniques which you need to know. There's 4 of them, as you saw in the previous slide on the specification. And I just want to highlight a few points here, starting with simple distillation. This is normally used to separate water from salt water, and water evaporates first because it has a lower melting point. So it evaporates first because it has a lower melting point, and then it goes up the round bottom flask into the condenser and then drops out into the beaker here. Now I want to just mention that water also goes in from the bottom, and that ensures that the condenser is completely filled. But if for some reason the water is cut off, the water flow is cut off, then the condenser would still be full. The water won't go back down into the tap. So it's important it goes in from the bottom and out from the top. Now the two processes here are evaporation, when the water evaporates, and then condensation, which happens in the condenser here. Now this is pretty much the same for fractional distillation, although fractional distillation just has this fractionating column in the middle, and this fractionating column contains either little glass beads or porcelain, broken ceramic, anything like that, anything which has a high surface area, and that just helps the separation of the two miscible liquids here. In this sense, we have water and alcohol. You could have water and ink or something like that. So you can use fractional distillation for salt water at the top, but it's a bit of an overkill. You don't really need to use it, but the fractionating column is important for separating two miscible liquids. So here the exact same principle applies, and you have the processes of evaporation and condensation. Now for your exam, you'll need to know how to draw and label the apparatus, so ensure that you know. Here we have 3 more separation techniques. The first one, filtration. Again, you'll need to know the apparatus and how to label it. Here we use filtration to separate sand from water. Now sand is not big enough to get through the holes in the filter paper, so it is left in the filter paper. It resides in the filter paper. This is why it's called the residue. Now the filtrate here is either the solvent, which is small enough to pass through the holes in the filter paper, or solvent or a solution, so we can have salt water passing through there, okay, because it's small enough. And this is called the filtrate because it's the thing that's being filtered. Crystallization, you will have come across this when we're talking about salts and creating salts from solutions in your acids and bases topic. So it's a very important process here because it helps us separate soluble salts from a solution. But what you need to remember is that you need to heat the solution until it's saturated. Once it's saturated, then the crystals can then start to form. If you leave it to evaporate from the saturation point, the crystals will form quite uniformly and regularly, and you'll get really nice crystals, and water will also be trapped in between those crystals. So you'll get some water of crystallization there. And in GCSE you normally make copper sulfate crystals, which always which per copper sulfate molecule has 5 water molecules trapped in the crystal structure per copper sulfate molecule. So the processes that happen here are evaporation, and I mean the first process is boiling. You boil the water, any excess water off, and then you leave it to evaporate once the saturation point has been reached. Once the saturation point has been reached, evaporation and crystallization happen at the same time. You want to slow down the crystallization process so you get bigger crystals, and we can do that by evaporating it. Okay. Onto paper chromatography. Here, paper chromatography is used to separate different dyes in a mixture. Now, the different dyes travel at different speeds, travel to different distances, depending on two things. That's depending on their attractiveness to the paper and their solubility. So when choosing our solvent here, we want to ensure that you choose the right solvent. That in this solvent, the solute doesn't dissolve too much in the solvent, or dissolves enough to actually be carried up the paper with the solvent. So here the processes that happen are dissolving. So as the ink moves up the paper, due to evaporation, so evaporation happens first. The dissolved ink moves up and it gets dropped off at the relevant places. Okay, here is an exam practice question for you. It's the same question you answered in your Year 11 January mocks, but a lot of people get it wrong. So please give yourself 5 minutes, 1 mark per minute, to answer this question, and replay once you've finished answering it. Okay, pause the video now. Okay, and then play. So many people just get 1 mark for this. They say the heat and boiling part, but they don't. You can only get 1 mark if you say all the water is evaporated or heated. To get 3 marks, you have to talk about. You have to heat the solution first until you get a saturated solution, and then leave to evaporate. But if you just mention leave to evaporate, then you'll get a maximum of 3 marks. You have to include this second part here, which is filter the remaining crystals, to get your 4th and 5th mark. Below is a chromatogram, which is a fancy word of the results that you get. And there are 2 things that you need to be able to do when you see a chromatogram. First thing is calculating RF values. RF values just tell us the distance that each ink moved in comparison to the solvent form. So here the solvent form looks like it's moved around 3.6 centimeters. Okay, now the RF values are always out of 1. They're a decimal out of 1. So if the solvent form is 1 whole, so that distance there that the solvent has moved is 1, then what decimal have these other inks moved? And just to show you how this gives a really good indication of the distance they've moved, I'm just going to predict these other inks. So let's pretend that this solvent form is 1, but it has moved 3.6. So this solvent form is 1. This green dot here, I'll predict that this is around 0.8. This blue dot here, this looks around 0.3. This green dot here is probably around 0.4. This orange dot here, let's say around 0.6. Let's see if we're correct. Now, when you're calculating them, you have to use the actual distances. Don't do what I've just done. It's because I've got an extremely mathematical eye. Don't do that. I was pretty close here with 0.81, and let's see how we did with the other ones. So 0.25, 0.3, that's close. 0.56, that's 0.6. Again, that's pretty close. So our predictions were correct. You can pause this to just see how these, to just get your mind around these calculations if that's still confusing. The second thing you also have to do is you have to be able to predict to identify which dyes make up your ink. So here's your ink, and you have to identify which of the dyes make up this ink, because remember it's a mixture and we're separating mixtures in this topic. So here I can say that we have D4, we have this dye, blue dye, because it matches. We have dye 1 because here it matches, and here we have dye 3 because there's a dye which has moved the same distance. Okay, so it's all about distance. Okay. Okay, here are some past paper questions. 4 marks, a mark a minute. You have 4 minutes to complete this. Pause now. Welcome back. Give yourself a mark if you've got them, and just put in your corrections if you haven't. Some more questions here. Again, it's a mark a minute. 4 marks. You have 4 minutes. Pause now. Welcome back. Great if you got these right. Give yourself a tick and put in your corrections somewhere.